So this is 3.2c, and I have a B there for some reason. Okay, let's change that to a C. In college algebra, and this section is called the quadratic formula. You recognize this formula, I'm sure, from past math courses. And what that is we took the general form of a quadratic equation here, where a, b, and c are numbers, and x's are x's. And what we did is we solved this for x. If you look on page 189, it goes through the whole solution process algebraically to set this equal to x. Okay, and when you set it equal to x, you get this. Okay, so a lot of students will use this because it's an easy method to find your x value, and then you plug your x value in, and you can get your y point or whatever you're looking for. But this is going to tell me where my parabola crosses the x-axis, okay, at two places. And well, I guess I should say a parabola is going to cross the x-axis at two places. It's going to, let me draw a graph here to give you an idea. It's going to cross at two places. It could cross at one place at the vertex, or it could not cross it at all. It could be completely off of it. So those are your three options for where your parabola crosses, and you can get a lot of information from just this equation, not even solving it, in order to determine what this parabola is going to look like. So that's the quadratic formula, and what you're going to do is you're just going to put numbers in here once I give them to you. So for example, if I give you, let me erase some of this, give myself a little more room here. If I give you 6 minus 3x squared plus 4x equals 0. Alright, first of all, what you have to do is you have to put it in this format, in that order, just because it's easier. So we're going to put the negative 3x squared first, then the 4x, and then the 6. And the reason we do that is because the number in front of the x squared is an a, and that's a b, and that's a c, and we need to have the right numbers here. And sometimes if you have it in this order, you might look at that as being the a, since it appears first there, and it's not. The negative 3 is the a. Alright, so once we do that, we write the equation with the right numbers in. Negative b would be negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4. What is a? A is negative 3, and c is 6. And the whole thing is over 2a. A lot of students don't realize that, and they stop it right there. But it is all over 2 times the a value. Oops. 2 times the a value, which is negative 3. Okay, and once we're at this point, we start solving. So what I need to remind you to do is solve what's under the radical sign first, and then we move out from there. So everything else just stays the same. So we have 16. We have two negative signs, so I know, because whenever we're multiplying numbers with positives and negatives, if I have an even number of negative signs, my answer will be positive. So I don't even have to think about that. And that gives me a 72 all over negative 6. Alright, so let's add those together. And you could have added those together prior to. Alright, so it's 88 over negative 6. Alright, so once we get to that point, we're still working on that. And my 88, if you remember right from when we did this before, I mean, this is just kind of the way I do it, is we have 2 times 2 times 22 under the radical sign, under negative 6. I pull the the couple out. I have a couple of 2's here. I can pull those out. So negative 4 plus or minus 2 times the square root of 22, because that's what's left over negative 6. And then I can start reducing. I can, the book just does it automatically, and that's what I've learned to do, but let's go ahead and split these up just because sometimes it's easier that way. Less confusing. So they're both over negative 6. So 4 over 6 is 2/3, positive 2/3 since I have two negatives. And 2 over negative 6 is negative 1/3. But because of the plus or minus here, the negative part here is kind of irrelevant. So square root of 22 over 3. And let's write this as one fraction then. So x equals 2 plus or minus the square root of 22 over 6. Or I'm sorry, over 3. Over 3. So if for some reason you want to graph these points, I mean this is these points, 2 plus the square root of 22 all over 3, and 2 minus the square root of 22 over 3. If you wanted to graph these 2 points, you're going to have to make your square root of 22 into decimals, and then add 2 and then divide by 3. So you get 2.230, and over here you're going to get negative 0.897. So x is an approximate. Decimals are usually an approximate, okay, because they go on and on and on. They're non-repeat. All right, they don't stop. So they're just kind of an estimate there, usually, especially with radicals. So if you wanted to graph that point, then you've got your 2.3-ish and a little less than 1 here, and you just kind of go from there. And because our A was negative, we know it's going to go something like that. We don't know the vertex at this point. So anyway, if you're going to graph it, change it to decimals. If you're not, I prefer leaving it like this because that's more exact. Decimal approximations of irrational solutions will suffice to applied problems normally. So when you've got story problems, go ahead and change it to a decimal, because the decimals are a lot easier to see in your head what's going on than something like 2 plus or minus the square root of 22 over 3. Okay, which brings us to example 9. In example 9, what they're doing is they're using your graphing calculator in order to find this, and they're giving you an equation there, and it's all in decimals, and it's a little bit harder to do when you've given the decimals, so that's why they're using the graphing calculator there. Alright, so you can look at that, go to page 191, the discriminant. Alright, again, hopefully you've are familiar with what a discriminant is. It's taking the quadratic formula and the discriminant is this part of the quadratic formula, not the radical, just the b squared minus 4ac. That is the discriminant. And what it does is it gives you an idea of what your answer is going to look like. Okay? So let's look at our different options here. If you do the discriminant, remember what I said when we did the last problem, example 8. I said we're going to do what's in the radical first. We're going to do what's under the square root sign first. That is the discriminant, and one of the reasons that you do that, besides it's just the first step, is it tells you what your answers are going to look like. If your answer to b squared minus 4ac is a number greater than 0. Let's say it's a positive 4 or a positive 1/2 or a positive 3/8. It's going to give you two different real number solutions. That is an R with a kind of a double leg there that I use as a symbol for real numbers. Alright, so it will give you two real number solutions. Just like on the last one I did, we got under the radical sign in number 22. Well, that is greater than 0. And yes, it did give us two real number solutions. It gave us 2 plus the square root of 22 over 3 and 2 minus the square root of 22 over 3. So if we do our b squared minus 4ac, and we come up with an answer of 0 under that radical sign. So if this ends up being 0, we have the square root of 0. There is one real number solution. And what we have is we do not have the plus or minus sign here because this number here is 0. So it doesn't matter if you add 0 or subtract 0, it's not going to change. So your answer is actually negative b over 2a. Okay? Which should bring back a little bit of memory when you're graphing parabolas as far as the axis of symmetry. Alright, if b squared minus 4ac is less than 0, if that means that you are doing the minus 4, or b squared minus 4ac, and let's say you get negative 22. Square root of a negative cannot be done, which means there is no real number solution, which brings us to imaginary numbers or complex numbers. Okay, so there's no real number solution because you cannot take the square root of a negative number. The square root of negative 4 cannot be found, because 2 times 2 is 4, but negative 2 times negative 2 is also positive 4. There's no number that will give you a negative 4 when you square it. So, there you go. One other thing I want to bring up here, they just kind of briefly make mention, I think later on in the book they'll probably go into it a little more detail, that sometimes, like if you have a quadratic equation like this, and you use the quadratic formula, you will find out that your answer is 3. Okay, what happens here is if you were to factor this, you're going to get x minus 3 and x minus 3 here, if you were to factor it. Which means your x value is 3, okay, but you really do have two answers. It's just both answers are the same number. And what they do with that is, when a number factors twice, like that, it is said to have a multiplicity of 2. It means that the same number is part of the answer twice. Okay? Alright, so when the discriminant equals 0, there will be only one solution to the quadratic equation, and it will have a multiplicity of 2. It will be like this one. It will have one answer, 3, but it'll occur 2 times, like we have here, giving us a multiplicity of 2. So whenever your discriminant is 0, you're still going to have two answers, but one solution, if that makes sense, because that one solution will occur twice, having a multiplicity of 2. If you look at the picture on page 192, table 3.3, it gives you the different type of answers you're going to get. So look at that to make sure that you're understanding what's going on there. Okay, so I'm going to stop this video here, and because I want to make sure that I talk just a little bit about complex numbers, imaginary numbers. The book doesn't even explain it in this part. It may explain it later on. You may have had it in Algebra 2 or Intermediate Algebra or something, but if you don't remember that, it'd kind of be nice to have a little bit more of an explanation than what the book gives here. So I will do a 4th video over that.